Okay, this first one is deceptively simple. It is basically, and I brought this diagram over because it makes a little, to me, it makes this make a little bit more sense. Well, another part of it. Anyway, this first part, C, determine expression for the magnitude of normal force in, really not sure why they named it that, but whatever, exerted on the block by the circular law as a function of V. Now, know that that V is going to change. There's going to be a point where this V is essentially V naught. It's like right here before friction really starts acting on it. That's what they're basically asking for. So let's look at this. You got your normal force, right? And I would probably just do Newton's second law, or I'd write by Newton's second law, normal force equals mass speed squared over r. That's it. Because look, could I put this as like n as a function of v? Yes, I could, however they want it, but I don't really think they take points off for that. Basically, it just means v needs to be in there, so it could be a variable if you wanted it to be. So yeah. And again, the way that they're asking it is priming you to screw up the next part, next two parts. Okay, so part D, derive an expression for the magnitude of tangential acceleration, oh my God, of the block at the instant the block has attained a speed of v. So at the instant it's attained a speed of v. This is also misleading because it's kind of leading you up. You know that there's going to be calculus somewhere, so they're trying to trick you into using calculus, both of these. You see function, you see instant, you're like, oh my God, calculus. Not yet. But the fact that they've given you those clues might come in handy in just a second. Because at this time, they really haven't asked us anything that is, you know, going to have so much to do with calculus. Because we're looking at just right once it gets to v, whatever that means. Okay, so the tangential acceleration. Let's look at this. This is why I brought this up. This is the centripetal acceleration, right? Well, look at this, because you know the path was circular, right? This part's going to be your tangential acceleration, which is actually slowing it down. So your force of friction, so again, I would go Newton's second law, and in this case, it's going to be, now notice it's slowing it down, so it's going to be negative force of friction equals mass times acceleration. All right, and I put, whoops, and therefore, remember, you're going to have negative mu. Force of friction is your normal force, so negative mu Fn equals mass times acceleration. Hey, look, we got we've got an expression for this that has speed in it for normal force. So we'll put therefore negative mu mass speed squared over r equals mass times acceleration. The masses cancel out. So you are left with negative mu v squared over r equals a tan. So yep, that's a function of speed. Yay.